I wanted to talk a little bit about the relationship between the graph of a function and its inverse. And many of you may have heard about the relationship between a function's graph and the graph of its inverse. And I wanted to kind of talk a little bit about where that might come from. And one of the ways that I like to do this is actually by using folding paper. So what I have here is, I'm going to take this away. This is actually some patty paper. And what that is basically it's the square pieces of paper that you might put between hamburger patties. And I like to use it sometimes for math demonstrations because it's semi-translucent. I can actually see through it a little bit. So if I draw on something like here, this is the side that I drew on this, but then I can also see the drawing through the backside. You can do some of this too just by drawing maybe with like a felt tip pen through a piece of paper, or using some waxed paper, or rubbing a little bit of oil on some white paper to make it a little bit translucent. Anyway, so that's what I have here, and I have used this. I started with a grid paper so that I could get a nice fine grid, and I graphed the function y equals 1/2 x squared. And I graphed it pretty precisely according to the grid. And I'm going to think about this when I'm talking about an inverse. What's happening when we do an inverse? When we look at an inverse function, this is, if you're looking at the outputs of a function, you want to know which input did this output come from. So the outputs become the inputs to your inverse question. The inverse question is, which input did this output come from? You're standing on an output value. And so what happens is you swap your input and output variables, right? So traditionally, we actually use the x-axis as our input variables and the y-axis as our output variables. So I want to think physically about what are the moves I would do in order to swap the x-axis with the y-axis. And I want to keep the orientations the same. So I want the positive x-axis to be moved to where the positive y-axis is, and the negative x-axis to move to where the negative y-axis is, and vice versa. And if you think about doing this just by looking at this graph, one of the things you'll notice is that in order to get the right orientation to swap the variables, you're going to actually have to get behind the graph, right? Because if I want to move this up to here, and I want to move this over to here, then what I've actually got to do is I have to be back here behind this and see this side. Right? So I'm looking at the back of that graph, so that movement actually needs to flip the paper. Let me make this a little bit more clear. Here's the x, this is the positive x, and here's the positive y. And I want to swap those. So now the positive y is down here and the positive x is up here. And if I think for a minute about how do I swap those? What is the movement that I'm doing here? And one thing that you can think about is, I can think about this as being kind of two movements. One movement is where I move the positive x up to where the positive y is. And then the second movement is where I move the positive y down to where the positive x is. Okay. So let me do that again, but I'm going to do this with an actual fold. So if I move the positive let me start with the original function. If I move the positive x up to where the positive y is and actually fold it when I do so, and I'm going to align the negative, this is the negative y. The negative y is going up to where the negative x is. Okay, and I fold with that alignment. Okay. And then I move that positive y down to where the positive x is. Okay. Then I can see that the movement that I'm doing when I do this swap of variables is I'm actually reflecting, I'm rotating or reflecting across this fold line. Okay, and the fold line is all of the places where the y coordinates are equal to the x coordinates. This is the line y equals x. Those are all the pieces that stay the same when you actually do that transformation. So here is my function. It is y equals 1/2 x cubed. And when I swap the variables, I get the inverse function, which is y equals the cube root of 2x. And this shows the relationship between the inverse function graph and the original function graph. The two graphs are a reflection of each other across that line y equals x.